Hey there, math enthusiasts. Welcome back to my YouTube channel. I'm Manny, and today we're going to be diving deep into factorizing trinomials. If you don't know how to factorize trinomials, if you know how to factorize trinomials but you find it very difficult, at the end of this video, factorizing trinomials will be easy for you. So bear with me. But before we get started, if you haven't already subscribed, please subscribe, like, share with your friends, comment below on some of the content you'd like me to cover, comment on anything that you'd like me to basically dive into. So yeah, let's get started. So before we start with factorizing trinomials, I want us to understand something. There's this thing called the skeleton. So the structure of a trinomial normally goes like this. Here we'd have ax squared plus bx plus c, right? A trinomial is mostly, or actually 99.999% of the time, the trinomial is what we call a quadratic expression or equation, right? So we have something like this. And after factorization, which is basically us breaking down this expression into its common factors, we'd have something like this. We'd have two brackets where here we have x plus b plus minus another term. It could be a plus minus. It could be either one of the two. It could be a plus or a minus on either side, right? So this is the full structure of obviously a trinomial when it's factorized. So how do we go about factorizing a trinomial? So the first example, let's say we're given something like this: x squared plus 7x plus 12. So let's say we're given an expression like this and they tell us to factorize, right? So the first thing we need to look at is the value of 12, right? So we need to look at the factors of 12 that if we add those two factors, they are going to give us 7. And if we multiply those two factors, they're going to give us 12, right? So if you know the factors of 12, it's going to be 12 times 1. It's going to be 2 times 6 and 3 times 4. And if we look here, we know that 12 plus 1 is going to give us 13, or 12 minus 1 is going to give us 11. 2 plus 6 will give us 8, and obviously 6 minus 2 will give us 4. But 3 plus 4 obviously gives us 12, and if we multiply them together, they give us 12. So these are the factors that we're going to be looking at. And in this case, if the coefficient of x squared here is 1, we don't have to suffer a lot. We just say x on one side and x on the other side, right? So now how do we fill in the rest of the terms? So pay attention. If the sign in front of the 12 is the constant, it's the one without a variable, right? If the sign in front of the constant, it's a plus, what that tells you is that the signs that we have to fill in here have to be the same. So the signs that we're going to be filling in here, they have to be the same, right? So if the sign in front of the 7x is a plus, it tells us that those signs that have to be the same, they both have to be a plus. And obviously, if it was a minus, both signs will have to be a minus. But we'll see a different example. So in this case, we know that the 12, the sign in front of the 12 tells us that the two signs have to be the same, and the plus tells us that those signs that are the same are a plus, right? So here we're going to say plus, plus, and then if the signs are the same, we don't have to worry about the order of how we add where we put the 3 and the 4. We can just put it anywhere. And in this case, if we put 3 and 4, we have our fully factorized expression. And in order for us to check that, we can FOIL it, where we multiply x with x and we get x squared, and we multiply x with 4, we get plus 4x. We multiply 3 with x, we get plus 3x, and we multiply 3 with 4, where we get 12. And obviously these two are like terms, and we'll add them together. Here we have x squared plus 7x plus 12. right? So that's basically the idea behind factorizing. So let's go back step by step and see what we did, right? So the first thing that we did was to what we did is obviously identifying the skeleton or the structure of how a trinomial looks when it's factorized. That's our step one. You need to know that, right? And as we said, if we have a trinomial like this, the first thing we're going to look at, if the coefficient of x squared is 1, the first thing we're going to look at is 12. And we're going to look at 12 and we're going to say, okay, what two terms or which two numbers can I multiply together that are factors of 12 that are going to give me 12, and if I add or subtract them, they're going to give me 7, right? And we determine that those two numbers are 3 and 4. If we multiply 3 and 4, we're going to get 12. If we add them together, we're going to get 7. And then, okay, we get back to our skeleton. So we draw a bracket here. We draw our two brackets, and when we draw our two brackets, we had something like this where we had x here and x here. And then now I said we're going to look at the sign in front of the 12. We're going to look at the sign in front of the 12, and if that sign is plus, it tells us that the two signs that we're going to have to fill in here, they have to be the same. We don't know what the signs are. They can be plus and plus or minus and minus. We still don't know yet. The only way we're able to know is if we look at the sign in front of the 7. And if we look at the sign in front of the 7 and we realize it's a plus, then we know that those two signs that have to be the same, it's plus and plus. And in this case, obviously it's a plus, it's plus and plus. And then those two factors that we found, we just fill them up here. We just fill them, sorry, that would be 4. That would be 4. Yeah, we just fill them up here and we're done factorizing. And in order for us to check, we can just multiply back all the terms, FOIL them out, and we're going to get back into our original expression, which is this one here. So that's basically factorizing. So now let's do another example to see if we understand. Okay, so we have another example here. We have x squared plus 3x minus 10, right? First step. We know that the coefficient of x is 1, right? So we need to write down our skeleton. And in many cases, if we write down our skeleton, it will look something like this. X and x, if the coefficient is 1. Now, we need to look at the values of 10 or minus 10 in this case, that if we add them together, they're going to give us 3x. If we add or subtract them together, they're going to give us 3x. And we know that the common factors of 10 are 1 and 10 and 2 and 5. And we know that in our world, 1 and 10 can never make 3, right? So we obviously know that we have to focus on 2 and 5. So how should we go about this? So we know that 5 minus 2 is equals to 3, right? We get that value, and 5 multiplied by negative 2 is equals to negative 10. So these are our two terms that we're going to focus on. So now, how do we go about filling them in there, right? Remember, in the previous example, I said if the sign in front of the 10 is positive, that means the two signs have to be the same. But in this case, it's negative. And the only way we can multiply two terms and we get a negative value, it's if those two terms have two different signs. So in this case, we have to have two different signs. So here we're going to put minus, and here we're going to put plus, all right? So now, where do we put the 5 and where do we put the 2, right? We've already determined that when we were busy trying to find out which factors here. We've already determined that 5 minus 2 gives us 3, positive 3, and 5 multiplied by negative 2 gives us negative 10. So we know that our 5 is positive and our 2 is negative. And if we FOIL this out, we know that we're going to get x squared if we multiply x by x, and obviously if we multiply x by 5, we're going to get 5x, and minus 2 multiplied by x, we have minus 2x, minus 2 multiplied by 5, that gives us minus 10. And obviously the middle ones are like terms, so we can always just add or subtract them. And in this case, if we add them, we have 3x minus 10, which takes us back into our original equation. So the steps are basically the same as the previous one. The only thing that changed here is obviously the sign of 10, or the constant, the sign in front of the constant, which is 10, right? It was a negative, so we know that with our skeleton, when we're drawing our skeleton here, we know that both brackets have to have different signs. Okay, let's look at another example. Here we have x squared plus 9x plus 20. Remember, first step, in this case we have the coefficient of x squared as 1. So our first step is obviously looking at the values of 20, that if we add them together, they have to give us 9, and if we multiply them together, they have to give us 20. And just to save time, I've already done my calculation, and I know that those two factors are 4 and 5. I know 4 multiplied by 5 gives me 20, and 4 plus 5 gives me 9. So now I go back to drawing my skeleton. I say x here, and then here the sign in front of the 20 tells me that the two terms have to be the same, and the two signs have to be the same in the brackets, and the plus in front of the 9 tells me that those two signs that have to be the same are plus and plus. And then I put my number here, I put my number here, and if I follow this out, I'll get back to my original equation. So I'm going to need you to try that out. I'm not going to try this out here just to save some time. Okay, so in the next example, we have 4x squared plus 40x plus 96. So how do we go about this one? Remember, I said if the coefficient of x squared is 1, we need to look at the constant. We need to start looking at the factors of the constant, right? But in this case, the coefficient is not 4. So what we need to look for first is a common factor between all these three terms. What is the common factor? Is 4 divisible by 4? We obviously know it's a yes. Is 40 divisible by 4? Yes. And 96 is also divisible by 4. So we need to divide all these terms by 4, or not even divide actually. We need to factor out 4. And here we know that if you factor out 4, we're going to have x squared remaining. And we know that 40 divided by 4, that gives me 10x. And 96 divided by 4, that will give me 24. 24, right? So now I have this. So in the next step, now I need to start looking at what's inside the bracket. I need to look at the factors of 20, that if I add them together, they're going to give me 10. And if I multiply them, obviously they're going to give me 24. To save time, again, I've already done my calculations, and I know that those factors are 6 and 4, right? So now I'm going to write down my 4 here, and then draw my two skeletons. I put my x here, I put my x here, and then remember, the sign in front of the 20, if it's a plus, it tells you that the two signs you're going to put in the brackets are the same. And the sign in front of the 10 tells you what those two signs are. So in this case, it's plus. So I know that here it has to be plus and plus. And it doesn't matter where you put your 6 and your 4. In this case, here we have 6. And obviously here we have 4. And if we multiply this back, if we multiply all this, or we FOIL this back, we're going to get back to our original equation, which is 4x squared plus 40x plus 96. Okay, so now we're going to try one more example, and then actually 2 more examples, and then that will be it for the end of the video. Okay, so now let's say we have 12 sorry, not 12 not 12 let's say we had something like 2x squared plus 3x minus 2, right? So I said if the coefficient of x squared is greater than 1 or is not 1, we need to look for a common factor between the three terms. Do we have a common factor in this case? Okay, we know that 2 is obviously divisible by 2. 2 is not divisible by 3, and obviously it's also divisible by negative 2, right? So we don't have a common factor in this case. So how do we go about solving this one? So there's a couple of ways, but I'm going to show you one way in which we can do it, right? So now what we do is we take the coefficient, which is 2, the coefficient of x squared, which is 2, and we multiply it with the constant, which is negative 2. So if I say 2 multiplied by negative 2, I know I get negative 4. So now I need to look at the factors of negative 4, that if I add them together, they have to give me 3x. And I know that those factors have to be minus 4 and 1, or minus 1 and 4, right? So I know that if I add 4 and or add 1, negative 1 and 4, I'm gonna get 3. What's this? I'm gonna get 3x, and obviously if I multiply it together, I'm gonna get negative 4. So let's put that in context and see how we're gonna solve this. So now those two values, we're gonna rewrite them here. So instead of writing 3x where there's 3x, we're going to substitute those two values with x. So let me show you how that goes. So we're going to rewrite this equation with as 2x squared plus 4x minus 1x minus 2. This is basically the same equation as the previous one, right? It's just that we rewrote 3x as 4x minus x, right? So in this case, we have 4 terms, and we already know that if we have 4 terms, we can always use grouping to factorize them. So in this case, we're going to look at the first 2 terms and see if they have a common factor, right? And the first 2 terms, they do have a common factor. Let me just change color. Sorry about that. Let me just change back color. We do know that they do have a common factor, and the common factor in this case would be 2x, right? So now if we take out 2x from 2x squared, we have x remaining, and if we take out 2x from 4x, we have 2, right? And then what about the last 2 terms, which is minus x minus 2? They do have a common factor, which is minus 1, and if we take out minus 1 from both sides, we have x plus 2 remaining, right? So now that we're here, if you see 2x multiply by this bracket and minus 1 multiplied by this bracket, if you see the 2 brackets have a common factor or are the same, so we call that a common factor. So they have a common factor. So we can rewrite this as 2x minus 1 and the other bracket which are the same, which is x plus 2. So that's how we factorize that one. So I know for some people there's a lot of confusion, but let's just see or go back and step by step and see what we did, right? So the first thing we said, if the coefficient of x squared is not 1, we always have to look for what we call a common factor, a number that can divide all 3 terms and leave no remainder. And in this case, we don't have any number. We don't have any value. 3 is not divisible by 2. So we don't have a common factor. So if we don't have a common factor, what we do is we say 2, which is the coefficient in front of the x squared, and this 2, negative 2, we multiply them together and we get the value of negative 4. So now we need to look for common factors of negative 4 that if we add together, they'll give us 3x or plus 3x. And we know that those two values are negative 1 and 4. If we multiply negative 1 and 4, they give us back our minus 4. And if we add them together, they give us 3. So now, we take these two values and rewrite them into the equation. So instead of us writing 3x, where there's a 3x, we're going to replace with those two values. So now we're going to rewrite that and say 2x squared plus 4x, the replacement, minus 1x, the replacement, minus 2. So if you see, the first and the last term, they remain the same. The only thing that changed is the way I rewrote the middle term, the 3x, right? So now after that, we have 4 terms. We have 1, 2, 3, 4 terms. And in many cases, when we have 4 terms, we can factorize using grouping. And that's what we're going to do. We're going to take the first 2 terms, which is 2x squared plus 4x. We're going to find a common factor, and our common factor was 2x. And what we have remaining is x plus 2. And with the minus 1x and minus 2, we do have a common factor, which is negative 1. And what we have remaining is x plus 2. So if you see 2x and minus 1, they do have a common factor, which is x plus 2. What's inside the bracket? And we can rewrite that as 2x minus 1 and x plus 2. So we're just going to do one more example and see if we can be able to understand from that. Okay, so now we have an equation that says 12x squared plus 7x plus 6, right? Okay, first thing, since we know that the coefficient of x squared is greater than 1, we need to look for common factors. I've already done it. I know that there isn't any common factor. So now what do? I need to multiply 12 with 6. And if I multiply 12 with 6, I get 72, right? So now I need to look at factors of 72 that if I add together, I'm gonna get 7x, and obviously if I multiply them together, I need to get back to 72. So what are those 2 factors? Okay, I know that 8 and 9 give me 72. I know that 2 and 36 give me 72. I know that 4 and 24 give me 72. I know that what is it? Sorry, I think I made a mistake somewhere here. No. 4 times 24 they don't give me 72. That's wrong. This one is not correct. Let me just get back to that. It's 4 and 18. It's 4 and 18, and obviously, as I said, it's 8 and 9. And another common factor would be 12 and 6. What are the common factors there? Okay. So with our last example, we have an equation that's like this. So we have 12x squared plus 17x plus 6, right? So as I said, if the coefficient of x squared is greater than 1 or it's not 1, we always have to look for a common factor within the 3 terms, right? So I've already done it. I know that there isn't any common factor since 17 is a prime number and it's only divisible by 17 and 1. So now, if you can't find a common factor that we can divide all 3 terms with, or we can take out in all 3 terms, what we do, we say 12 multiplied by 6. And 12 multiplied by 6, 12 multiplied by 6 will give me 72, right? So now I need to start looking at the factors of 72 that if I multiply together, they're going to give me back 72. And if I add them together, they're obviously going to give me 18. So those 2 factors are 8 and 9, right? How do I know this? Because I've already done the equation. Okay. So now that I know that, where there's 17, I'm going to replace with these two terms. I'm going to replace with 8 and 9, right? Because I know they add up to 17. So I'm just rewriting the equation with the two terms. So now I'm going to say 12x squared plus 8x plus 9x plus 6. I know my x looks too weird. It's because I'm left-handed, and yeah, it's a story for another day. Anyways, so now I have 4 terms. So now with these 4 terms, I know that every single time I have 4 terms, well, not every single time. In many cases, when I have 4 terms, I'm able to factorize using grouping, right? And in this case, I'm going to look at the first 2 terms. So I have 12x squared plus 8x. And what's the common factor there? I know that the common factor will be 4x. So if I take out 4x, or if I divide 12x squared with 4x, I have 3x remaining. And from if I divide 8x with 4x, I have 2 remaining, right? And from these 2 terms, 9 and 6, I know that my common factor will be 3. So if I take out 3 here, I have 3x. And if I take out 3 from 6, I have 2, right? So now you see that these 2 terms are the same. So what am I going to do? I'm going to rewrite this as 4x plus 3, put it in one bracket, and whatever was inside that other bracket, I'm just going to write it down like this. So that is how I factorize my full equation. So there's a bit of confusion somewhere. I heard someone asking me this question. They were like, sir, what if, how do I know when I replace the 17, which term to start with? And I say it doesn't really matter, right? So let's say, for example, instead of writing 12x squared 8 plus 8x plus 9x plus 6x, I swapped those 2 middle terms around, right? So let's say I swapped them around and I wrote it down like 12x squared plus 9x plus 8x plus 6. Let's say I swap them out like that. Okay, so now I'm going to focus on the first 2 terms. I'm going to try to find a common factor, and I know that my common factor is 3x, and I have 4x plus 3 remaining. And with the 8 and 6, I know that my common factor will be 2, and I will have 4x plus 3 remaining, right? And then I'm going to rewrite this as 3x plus 2, and obviously 4x plus 3. So I kind of get back to kind of like the same answer. So it doesn't really matter how you kind of arrange them. You'll always be able to factorize using grouping either way. So that's it for this video. Don't forget to like, subscribe, share with your friends, and tell them about ASW tutors, and see you in the next video.